Hi guys, in this lesson we're going to learn how to factor, focusing on pulling out common factors, and also we're going to practice the pattern called the difference of two squares. The first step of factoring will always be to look for a common factor. So if we look at the number part, what number divides into 6 and 15 other than just 1? Hopefully 3 occurs to you very quickly. Is there any other number that divides into 6 and 15? Be careful to consider the 6 itself. Does 6 divide into 15? Because it definitely divides itself. Well, no, 6 does not go into 15. So 3 is the greatest common factor between 6 and 15. So we're definitely going to have 3 as part of the common factor. Now look at the variables. Determining the greatest common factor between variables is easy. It's always going to be the lesser amount of the variable. So in this case we have 3 x's in the first term, 1 x in the second term. So I like to think of it as both terms have at least 1 x, so that's the GCF there. Once we have the GCF, what we do is we make one set of parentheses, we put the GCF in front. To decide what's going to go on the inside, please understand that what you will actually do will be division. If you take that GCF, greatest common factor, and divide by it, that's going to let you know what will go inside. So 6 divided by 3 is 2. X to the third power divided by x is x squared. One time real quick off to the side, when I say x to the third power divided by x, in my mind what I'm picturing is x to the third power is x times x times x. And then I've got this x in the denominator. So what's happening is the x in the denominator is canceling out one of the x's in the numerator, and that's leaving 2 x's. That's why we're getting x squared. Alright, just a quick review right there. Anyway, plus, now 15 divided by 3 is 5, and these x's cancel out. So this is going to be the answer in terms of factoring. Now if you were going to check your work, which is always a good idea, one thing you would do is do the distributive property. If you do the distributive property, you should get back to what you started with. So 3x times 2x squared, that should give us 6x to the third power. 3x times 5 is going to give us 15x. And then you look back and see, yep, that's what I initially had. Okay, that type of check doesn't actually guarantee that you did it right, because maybe you pulled out a common factor but not the greatest common factor. But still, it will help you avoid many types of mistakes. Okay, let's slide over and look at number 2. Alright, as I go, I'm going to be going a little bit faster. So first, look for a common factor between 10 and 15. They are both divisible by 5. So let's go ahead and pull the 5 out. Now look at the x's. 2 x's, 1 x. The lesser amount is 1x. Now look at the y's. 1y, 2 y's. The lesser amount is 1y. So that's how many I can pull out. Go ahead and make one set of parentheses. To figure out what goes on the inside, you divide by the GCF. So divide by 5xy. Okay, 10 divided by 5 is 2. X squared divided by x is x. And the y's here cancel out. I see the minus. 15 divided by 5 is 3. These x's cancel out. And y squared divided by y is y. Okay, so that is going to be the answer right there. How about number 3? So, looking at the 28 and the 14, 2 was a common factor, 7 was a common factor, but 14 is itself a common factor. And we have to use the 14 because that's the greatest common factor. So let's pull out that 14 and see what happens. Now, variable-wise, I'm going to go with x squared because that's the lesser amount. Okay, so let's divide by our GCF. Okay, 28 divided by 14 is 2. Okay, 2 times 14 is 28. These two x's are going to cancel out 2 of these x's and leave 3 x's. Now, 14x squared, 14x squared. Anything divided by itself is 1. So this would be the answer right here. Okay, that was a little tricky. Let's look at number 4. Again, we have to be careful to look for the greatest common factor. Number 4 can be a little bit tricky because both of these numbers have a lot of factors. Start with the smaller number, 24. Start to ask yourself, what are all the things you can think of that divide evenly into 24? For this unit, for this part of the unit especially, I'm really hoping you're one of the people who knows their multiplication tables. Because if you don't know your multiplication facts, you know, up through 12, that's going to cause some problems. Because I'm hoping you can look at 24 and think to yourself things like, oh, okay, well, this is divisible by 2, okay, because that's 2 times 12. And it's also divisible by 3, because it's 3 times 8. And it's also divisible by 4, because that's 4 times 6. Things like that. If so, then at a glance you look at 24 and you think, okay, I've got the following factors, 2, 3, 4, 6, 8, and 12. Alright, I've got those 6 factors that jump into my head. You know, of course, 24 times 1. So 24 is another factor to think about. So we want the greatest common factor, so let's start at the top. Let's start with the 24 itself. Does 24 go evenly into 64? I think not. I know that 2 24s is 48 and 3 24s is 72, so that takes us past 64. But if you didn't know that, you might try to divide it. 64 divided by 24, and you see, nope, it doesn't go in evenly. So 24 is not a common factor. So go down the list. What about the next bigger one? 12. Does 12 go into 64? Again, I think not, but feel free to check it out. 64 divided by 12. Nope, that's a decimal as well. It does not go in evenly. Let's see, what's next on the list? The next biggest number, because we are looking for the greatest common factor, is 8. Now hopefully you know your multiplication facts are starting out here. So 8 definitely goes is a factor of 24 and 64. So 8 is the greatest common factor between those two numbers. So let's go ahead and pull that out. Now the variable part is easy. Just go with the lesser amount, so x to the 5th power, and set up your parentheses. Understand that you will be dividing by that GCF to see what goes inside the parentheses. 64 divided by 8 is 8. These 5 x's will cancel out 5 of these x's and leave 3 x's behind. I see the plus sign there. Now 24 divided by 8 is 3. And these 5 x's will cancel each other out. So this is the answer. Alright, well next we're going to get into something called the difference of two squares. And let's start off simple. Let's say if I have x squared minus 36. That's going to factor as x plus 6 times x minus 6. Okay, this is called the difference of two squares because 36 is one of our perfect squares. It's 6 times 6. X is also a perfect square because it's x times x. Why did I put a 6? Okay. So, and of course the difference means subtraction. So this is the difference of two squares. Let me see if you can follow the pattern again. Say if I have x squared minus 49. How would we factor that immediately? Hopefully you said, oh, well that's going to be x plus 7, x minus 7. Okay, one more. What if I had, let's see, x squared minus 81? How would I factor that? Alright, did you just say x plus 9, x minus 9? Well, you're a genius. Now, we can mix this up and put additional squares as coefficients. Alright, let's see, what have I not used yet? Let's say this was, instead of just x squared minus 36, let's say it was 25 x squared minus 36. Okay, so now we have to factor that as well. So instead of just being x plus 6 times x minus 6, it would be 5x plus 6 times 5x minus 6. Okay, let's see, what else have I not used yet? What if this was 4x squared minus 49 instead of just x squared minus 49? What would I have now? Well, this would have to become 2x plus 7 and 2x minus 7. You simply factor the 4 down. Alright, have I left anyone out? Alright, oh yeah, well, alright, the 9 is already there. Okay, you get the point. In fact, what if I did this? What if I threw a y squared in here, just for fun? So instead of just being x plus 9, x minus 9, it would be x plus 9y, x minus 9y, because I could factor that y squared as well. Okay, so that's how the difference of two squares works. So take a look at number 5. So just immediately you should be able to tell me how to factor this thing. Alright, what do you think? Okay, this is going to be, whoops, 4 is going to factor as 2 times 2, right? So it's going to be 2m plus 5 and 2m minus 5. Kabam! Now, by the way, let's check this one. I'm not going to do this for every problem, but let's see why the difference of two squares works. The way I would check this is by doing the double distributive property. So let's do 2m times 2m, and so that's going to give me 4m squared. And then 2m times negative 5, that's going to be negative 10m. Okay, now let's distribute the 5. So 5 times 2m, it's going to be a positive 10m. And 5 times negative 5 is negative 25. Okay, now if we factored correctly, this should get us back to where we started from. But look how long this is and look how short this is. Yeah, I mean, you understand what's happening here. These two are going to cancel out. We have a minus 10m and a plus 10m. So that's going to leave us with 4m squared minus 25, which is exactly what we started with. So that's why the difference of two squares works. Alright, see if you can say how to factor this before I can write it. Hopefully you said x plus 8, x minus 8, okay? Difference of two squares. Okay, so number 7, we're getting away from the difference of two squares for a minute and going back to the greatest common factor. Actually, this video is getting a little long. I'm going to stop the video here and we'll do the rest on the next video.